In the quiet reaches of interstellar space, far beyond Neptune's cold frontier, a faint traveler drifts toward the Sun. It is known as 3I ATLAS, the third confirmed object ever observed entering our solar system from another star. Neither a typical comet nor an asteroid, it's something in between, a frozen messenger from the distant past. The discovery of the object was first spotted by the Atlas survey in Chile on July 1, 2025. Its motion immediately stood out. It was moving too quickly to be bound to the Sun, tracing a hyperbolic path that ensures it will never return. NASA's Jet Propulsion Laboratory confirmed its interstellar origin, and telescopes across the world began tracking it. Its approach speed exceeded 25 kilometers per second, faster than any ordinary comet known within our solar system. Archived observations soon revealed its faint trace even before its official discovery, proving it had already been crossing the inner system unnoticed. When the Hubble Space Telescope captured its image, it showed a faint teardrop-shaped cloud, a coma of dust and gas trailing an unseen nucleus. Scientists estimated the core to be smaller than 6 kilometers across, possibly much less. 3I ATLAS would make its closest pass to the Sun on October 30, 2025, at roughly 1.4 astronomical units, and to Earth at about 1.8 astronomical units, distant, but well within the range of modern instruments. A strange chemical signature. The James Webb Space Telescope, observing in infrared wavelengths, recorded something remarkable. Its spectra revealed a coma dominated by carbon dioxide, with a carbon dioxide to hydrogen oxide ratio nearly 8:1, one of the most extreme ever seen. Small amounts of water vapor, carbon monoxide, carbonyl sulfide, dust, and ice grains were also detected, but carbon dioxide clearly dominated. This suggested an unusually carbon-rich composition, or perhaps that water sublimation was being suppressed deep inside the nucleus. Then came an even more astonishing discovery. Using ultraviolet emission data, scientists detected clear evidence of hydroxyl O radiation, a byproduct of water molecules broken apart by sunlight. This was proof that 3I ATLAS was releasing water, even while more than 3.5 astronomical units from the Sun, a distance where most comets remain frozen solid. The finding, published in the Astrophysical Journal Letters, marked the first confirmed detection of water activity in an interstellar comet. The outflow was measured at roughly 1.35 times 10 squared to the power of 7 molecules per second, about 40 kilograms of water every second. Dust like no other. Meanwhile, polarimetric measurements, which study how light scatters through dust, revealed something never seen before. The comet's coma displayed an extreme negative polarization, dropping to nearly -2.7% at a 7 degrees phase angle, with an inversion around 17 degrees. No other comet or asteroid has ever shown such a signature. This indicates that the dust grains of 3I ATLAS differ radically from any known within our solar system, perhaps shaped by billions of years of exposure to cosmic radiation and the harsh interstellar medium. When the comet passed near Mars in early October, ESA's Mars Express and ExoMars orbiters captured distant images of its diffuse halo, though no visible tail was resolved. Its behavior suggests it could be among the oldest cometary bodies ever observed, possibly predating the birth of our own solar system by billions of years. A debate rekindled, as with its predecessors, Oumuamua and 2I Borisov. Speculation followed quickly. Some claimed the object might be artificial, perhaps a fragment of alien technology or a derelict probe. However, NASA dismissed these ideas, confirming that all observed behavior matched natural cometary processes. It poses no threat to Earth and continues its journey silently through the inner system. Brightness measurements in July suggested no major outbursts, and minor fluctuations were later traced to background stars, not real changes in activity. This stability only deepened the mystery of its composition and structure. A glimpse into galactic history taken together, the data paints an extraordinary picture. 3I, Atlas is a cometary body born around another star, likely from a region poor in heavy elements, a remnant of an older generation of suns. Its strong carbon dioxide emissions, active water venting, and dust with alien properties reveal a chemistry shaped in a different corner of the galaxy. Each molecule vented from its surface tells a story, not just of ice and rock, but of the conditions that once existed in an ancient planetary system. By studying it, scientists are peering into a time when the Milky Way was still forming its earliest worlds. As 3I, ATLAS approaches its perihelion, the point closest to the Sun, scientists expect its activity to surge. With rising solar heat, layers of frozen gases buried deep within its nucleus may awaken, venting plumes of vapor and dust that could briefly brighten the comet, offering one last opportunity to study its alien chemistry in greater detail. But time is running out. Once it swings past the Sun, 3I, ATLAS will begin its long retreat, accelerating outward beyond Jupiter's orbit, fading into the vastness once more. Its path will carry it beyond the gravitational grasp of our star, into a realm of eternal night, where sunlight is nothing more than a distant memory. Around the world, telescopes are watching, from NASA's Deep Space Network to the European Southern Observatory, from the Hubble Space Telescope to the James Webb itself. Each observation, each photon captured, is a piece of an ancient puzzle, a way to understand not just the comet, but the story of how stars and planets share their material across the galaxy. The discovery of 3I, ATLAS has reignited a global effort to prepare for future encounters. The upcoming Vera C. Rubin Observatory will soon scan the entire night sky every few nights, searching for fast-moving interstellar visitors like this one. And engineers are already designing interceptor spacecraft, rapid response missions that could launch within months of discovery, intercept such objects in deep space, and perhaps collect direct samples. One such proposal, the interstellar probe concept, envisions a spacecraft capable of chasing an object beyond the orbit of Neptune, equipped with advanced propulsion and instruments able to analyze its composition up close. If such missions succeed, humanity could one day touch, quite literally, the building blocks of another star system. Each new interstellar visitor teaches us not only about distant worlds, but also about our own cosmic origins. Because every grain of dust that drifts through the interstellar medium carries the memory of ancient suns, the ashes of long-dead stars, the molecules of potential life, and the chemistry of creation itself. The legacy of 3I, ATLAS. Expanded version. Even as 3I, ATLAS grows fainter and begins to slip away, its legacy is just beginning. Its discovery has challenged the boundaries of what we thought comets could be, revealing a body both familiar and foreign, a mixture of ices, gases, and minerals shaped in an environment completely unlike our own. It has shown that water and organic molecules can exist and survive even in the deep cold between the stars. It has forced scientists to reconsider how planetary systems exchange material, how fragments from one star's cradle can travel for billions of years before brushing past another. This exchange, this galactic circulation of matter, may be one of the most profound processes in the universe. It means that the atoms in Earth's oceans, the dust beneath our feet, and even the molecules in our bodies could once have drifted between stars, carried by wanderers like 3I, ATLAS long before our sun was born. Every interstellar object is a time capsule, a frozen relic from an era when the galaxy was young and turbulent. By studying them, we are reading the earliest chapters of cosmic history, stories written in ice and dust rather than ink and paper. 3I, ATLAS stands as a reminder that our solar system is not isolated. It's part of a larger, interconnected galaxy, where fragments of ancient worlds wander freely, spreading the raw materials of life across unimaginable distances. To witness such an object is to look beyond the boundaries of our home, to glimpse the biography of the Milky Way itself, written across eons of space and time. Each molecule escaping from its surface carries a whisper of another world, a world that may have once orbited a long-vanished sun. And as 3I, ATLAS fades back into the dark, it leaves behind a profound message: that the universe is not silent, nor empty, nor still. It's alive with movement, with exchange, with whispers from forgotten corners of creation. Someday, we may build the technology to chase one of these travelers, to meet it, study it, even touch it, and learn firsthand the secrets it has carried through the ages. Until then, we can only watch and listen, knowing that every interstellar visitor is a messenger. A messenger not just from another star, but from the shared story of everything that has ever been.